Hello and welcome to another marathon series for A-level math. Today's topic is differentiation for P3. Um, this worksheet that I'm going to solve has a lot of past paper questions. If you wish to download this worksheet, the link will be provided in the description below. If you want a solved version of the worksheet, there will also be a link for that. Please make sure to like and subscribe as you are watching this video. The first question is from June 2007. Question 3. It says the equation of a curve is y equals to x sine 2x, where x is in radians. Find the equation of the tangent to the curve at the point where x equals to pi over 4. So this looks like a simple question on product rule. Let's talk about the product rule. The first expression in the product rule is called u. The second expression is called v. You differentiate each of these. U bar gets you 1 and V bar gets you cos 2x into 2. Then you write this as dy by dx u dash v plus v dash u dash v plus v dash u. And what I end up getting is sine 2x plus 2x cos 2x. The question is asking me for the equation of the tangent, so I'm going to say that I have to plug in the value x equals to pi over 4 sine 2 times pi over 4 plus 2 times pi over 4 times cos times 2 times cos into 2 times pi over 4. Solving this further gives me dy by dx at x equals to pi over 4. So sine of 2 pi over sine of pi over 2 is basically 1 plus 2 times pi over 4, and cos of pi over 2 is 0. So that gives me the gradient as 1. I have the x coordinate. Can I quickly find out the y coordinate? Pi over 4 sine times 2 pi over 4. So that gives me y as pi over 4. So y minus y1 mx minus x1. So that gives me y equals to x minus pi over 4 plus pi over 4. That gives me y equals to x. That is the first question. This is the second question. At each question, I would encourage you to pause the video and solve the question yourself and then look at the answer that follows. It says the curve will with equation y equals to 6e power x minus e power 3x has one stationary point. Find the coordinates of that stationary point. So y equals to 6e power x minus e power 3x. dy by dx is 6ex minus 3e3x, e power 3x into 3 basically. Now I have to find the x coordinate of the stationary point. Remember that always these expressions that you get from differentiation on P3 will give you some common in the answer options. So when I pull out e power x as common, I'm left with 3e2x. So either e power x can be 0 or 6 minus 3 e power 2x is 0. Okay, solving this further gives me 2. I use an ln, ln2. So ln e power 2x, the power climbs down, ln e is 1, so I get x equals to ln2 divided by 2. Find the x coordinate of that point, so I've already found that. Part 2 says determine whether it is a maximum or a minimum point. Now there are various ways of doing that. I have my dy by dx in front of me. What I can simply do is, instead of trying to double differentiate, I can also plug in values near the gradient. That's something that I do in the videos as well. You can go back to the lecture videos and find out. Here the double differential seems reasonably simple, so I'm just going to do that. I'm going to say that this differentiates to, again, 6e power 3x, and sorry, I've written this wrong. This is 3e3x. So this becomes 9e power 3x, and when I plug in ln 2 divided by 2, let's see what happens. Okay, I am going to use my calculator to do all of this. I can do it manually as well, but I just don't want to spend too much time thinking about the answers on the exam. So I will just use my calculator to get you a final answer. This gives me minus 16.97, negative, therefore maximum. Okay, the double differential is negative, therefore the value is maximum. Moving on, this is question number 3. Again, I would encourage you to pause and solve the question yourself before you look at the solution. The diagram shows the curve y equals to ln x divided by x squared and its maximum point m. The curve cuts the x-axis at A. Write down the x-coordinate of A. This is a 1-mark question, so I'm possibly asking you for something simple here. A is the x-intercept, so I can tell you that at this point y will equal to 0. So 0 equals ln x divided by x squared. I get this cross multiplied. This becomes 0 equals to ln x. And then e power 0 is the reverse. If you reverse ln, you get e on the other side. So this becomes e power 0. So that means x is 1. Write down the x coordinate of A. So that's what I've already written. That is 1. Find the exact coordinates of M. Again, I'm asking you to differentiate. This time it's the quotient rule. I have a numerator and denominator, so I'm going to say that u is ln x, v is x squared, v dash is 2x, u dash is 1 over x. Some people tend to convert it into a product rule and then solve. I wouldn't encourage you to do that, but it would still solve the problem. Then dy by dx is u dash v. Okay, let me just first write that down so that we don't make a mistake. U dash v minus v dash u over v squared. Okay, v dash u v squared. Again, I'm trying to find a maximum point, therefore dy by dx should equal 0. So I get x minus 2x ln x over x power 4. Cross multiply this, I get 0. It's common, 1 minus 2 ln x. And 1 minus 2 ln x. Either this equals to 0 or that equals to 0. Let me just try that. So x equals to 0 is not what I'm looking for. There might be a turning point there, but I'm looking for a positive x coordinate. So 1 over 1 equals to 2 ln x. Ln x equals to half. X equals to e power half. Okay, and that should be your answer. Okay, then this is a slightly tough question. Let's look at that. Part 1 says the polynomial f of x is in the form x minus 2 whole square g of x, where g of x is another polynomial. Show that x minus 2 is a factor of f bar of x. Okay, so f bar of x has to be calculated. Can I say that it's again the product rule? There are two expressions that are multiplying together. Yes, the second expression is not visible to me, but I can still try to solve it. So u dash gives me 2 times x minus 2, and v dash gives me g bar of x. Again, g bar of x is something I don't know. So f bar of x then becomes u dash v plus v dash u. Now I'm asking you to prove that x minus 2 is a factor of f bar of x. This is the remainder factor theorem, that if I plug in 2 into this entire expression, what I know is that this should boil down to 0 I if x minus 2 is a factor. X equals to 2 when plugged into the equation should give you 0. Let's see if this becomes 0. This becomes 0, so that entire term becomes 0, and this also becomes 0. So f bar of 2 is basically 0 plus 0, which is 0. Therefore, x minus 2 is a factor. Okay, that's the first. The second one says the polynomial x power 5 plus ax power 4 plus 3x cube plus bx square plus a, where a and b are constants, has a factor x minus 2 whole square. So this looks like something that f of x had. Let's see what it says beyond that. It says using the factor theorem and the result of part 1 or otherwise. Now, first let's talk about what or otherwise is. We've all done in the remainder factor theorem that if you have one of the factors, what you can do is you can start doing a comparison as long as the powers are equal. So I can put out an expression that says cx cubed plus dx squared plus ex plus f. I've put it to cubic because I wanted to make these powers equal to 5, and that should balance, and then I can start doing a comparison. It's going to be a long sort of solution, but you will end up with a final answer. Why? Because you have enough comparisons to do. And to be honest, the question solves with that. But since this is the second part of the question, I should be able to figure out what I have to do in the second part that involves the first part. So it says using the factor theorem and the result of part 1 or otherwise. What is using the result of part 1? So can I say that this is basically g of x? Okay, and this is basically my f of x. So I just figured out from part 1 that x minus 2 was a factor of f of x, and it was also a factor of f bar of x. So if it is a factor of f of x, can I go on and say that 2 power 5 plus a into 2 power 4 plus 3 into 2 cubed plus b into 2 squared plus a should equal 0? So I get 32 plus 16a plus 24 plus 4b plus a equals to 0. I get 56, and 17a plus 4b equals to minus 56. That's one equation, and surprisingly it just has two unknowns, a and b, which means that I should find another equation that has two unknowns only. I know that another equation that should have two unknowns is f bar of x. Let's first calculate f bar of x. So I'm going to differentiate each of these. I'm going to say 5x power 4, 4ax cubed, 9x squared, 2bx plus a. Oh, sorry, a is going to get differentiated. Okay, so can I say again that when I plug in 2, I should get 0? Why? Because from the previous part, I've proved to you that um, f bar of x has a factor 2. 5 into 16 is 80 plus 4 is 32a plus 36 plus 4b. So I get minus 116 equals to 32a plus 4b. Now on the exam, you would have to show me a method for solving simultaneously. Here for the purpose of this video, I'm just using my calculator since my calculator is able to do all of that, and it is able to do it quickly as well. So I'm just going to speed that up and solve simultaneous equations on my calculator. So I get a as -4 and b as 3. Do we have answers here? Yes, a as -4 and b as 3. So relatively small question for 5 marks. Let's look at question number 5. It says the equation of a curve is this. Find the x-coordinates of the stationary points in the interval x is between 0 and pi, giving each answer correct to 3 significant figures. Again, okay, I am going to um, differentiate this and say that this looks relatively simple though. Why is it so many marks? Dy by dx, the differential of cos is minus sine, so I get 3 minus sine 2x into 2 plus 7 cos x plus 2 plus 0, sorry, plus 0. So 0 minus 6 sine 2x plus 7 cos x. Okay, now I will have to use some form of identity to do this. Minus 6 to sine x cos x is the identity for the double angle sine 2x, 7 cos x. So that gives me minus 12 sine x cos x plus 7 cos x. I will factor out a cos x and say that this is minus 12 sine x plus 7 equals to 0. So either cos x equals to 0 or minus 12 sine x equals to 0. Now sine x is therefore minus 7 over minus 12, which gives me sine x as 7 over 12. Remember that your calculator always has to be in radians. It cannot be in degrees for these questions on differentiation. Now for 0, what I simply tell my students is that since it's a neutral number, it's in all 4 quadrants, you go on and calculate cos inverse of 0, and that gives you pi over 2. I don't really need to look at all quadrants. I just need to go up to quadrant number 2. It's 0 to pi. So quadrant 1 is going to be pi over 2, and quadrant 2 is going to be pi minus pi over 2, which is a repetition of the original answer. So I just have one answer technically from here. Then I have two answers from here, quadrant 1 and quadrant 2, sine inverse of 7 over 12. And what do I get? My calculator is in radians, just making sure of that. I get 0.623. So quadrant 1 becomes 0.623. Is that the right answer? Yes. And quadrant 2 is pi minus 0.623. That's 2.52. So the three answers are 0.623, 2.52, and pi over 2. You should always write down the answers at the end as a list so that the examiner knows where your answers are. Okay, question 6 tells me that the equation of a curve is this. Obtain an expression for dy by dx and show that it can be written in the form this, where a and b are constants. Okay, so let's start differentiating this. Minus 2e minus 2x. Okay, let's just instead write u and v so that you don't end up being confused. I have a habit of sometimes doing all of this directly in my head, but it may lead to an error. Let's just try to avoid that. So u dash is minus 2e minus 2x. So dy by dx then gives me u dash v plus v dash u. Okay, now my question is that it can be written in the form a plus b tan x whole square. Okay, so what I first end up doing is I end up pulling out e power minus 2x common. That gives me minus 2 tan x plus sec square x. Okay, then what I see is that I don't need a sec square x, I just need tan. So I remember my identities and I say that sec square x can be replaced with 1 plus tan square x. Okay. Now, somehow I need a whole square outside. I know that when I have a whole square outside, what I'm talking about is something along the lines of a square plus 2ab plus b square. If I have the terms in this format, they close down to the bracket a plus b whole square. Can I show you this conversion? Can I show you that what I have here is 1? I've just rearranged them and said this. So this looks like a square. Why? Because it's the square of 1. This looks like b squared. This is the square of b. Is this 2ab? Yes, that looks like 2ab. Even if you weren't able to do that, you would uh, get the same answer if you broke the middle term, factorized it by putting it in pairs, and then coming up with the final answer. So I get e power minus 2x, and this becomes 1 minus tan x whole squared. So I've proved to you that a is 1, b is also 1, and I have this in the format. Okay, that's the first part of the question. The second part says that once you've proved that this is the case, e power minus 2x 1 minus tan x whole squared, you have to prove that the gradient of the curve is never negative. When I'm talking about never negative, I'm talking about it's either 0 or positive. Okay, let's look at that. So the result of this bracket, now it says explain, so I never need to write an explanation. So I'm writing that explanation. The result of this bracket is always positive or 0 because of a square outside. The result of an exponential for all values of x is always positive. Therefore, the entire expression for dy by dx is always positive. Okay, part 3. It says find the value of x for which the gradient is least. Now, what a lot of people think is that this question is then about sort of differentiating again, or just equating it to 0 and all of those things. Remember that if you start doing that for a 1 mark question, you will probably never see the end of it. This question is about something else. It's just about analyzing what the situation is. You've already declared in the previous part that this is never negative, or that which means that it is either 0 or positive. So the first thing that comes to mind is that if I'm asking you for the least possible value, then it should be 0. Let's see if I can make this expression 0. This can't go to 0. This cannot be 0. When does this bracket equal to 0? Can I think of something like that? Okay, so I see something that tan x, it's 1 minus tan x. So if I were able to generate 1 minus 1, I could possibly get that. I will just simply put out 1 minus tan x equals to 0 and see if that works. When is tan x 0? Now I have to have an answer in the first quadrant. Why? Because it says 0 to pi over 2. So I'm just going to go with tan inverse of 1. I put it out on my calculator and I get pi over 4. So x is basically pi over 4. So that's the value of x that leads to a gradient of 0. So the next question is from June 13. The diagram shows the graph, the curve this, and its maximum point M. So I'm again looking for a maximum point M. It says find the x coordinate of M. So again, this should be about differentiation. And I'm going to again use the product rule and say that y equals to sine squared 2x cos x. So I have u and I have v. I can say that u dash equals to, I will first employ the power rule, cos 2x into 2, and v dash will be minus sine x. I think that is relatively simple. So I have dy by dx as u dash v plus v dash u. U dash is 4 sine 2x cos 2x into cos x u dash v plus v dash u. So I equate this to 0. I find out that cos x is common. You will always, sorry, sine 2x is common. Um, u dash v. That is also an error. Let me just correct that. V dash u, sorry, sine square 2x. So I find out that sine 2x is common. So 4 cos 2x cos x minus sine x sine 2x sine 2x. Yes. So either this equals to 0 or that equals to 0. So what I end up doing is I end up solving the first one first. I know that my answer should uh, be between 0 and pi over 2, so 0 and 90 degrees basically. So I start solving the first one. Since it's 0, I mark all the quadrants. I don't really need to go on to quadrant 3 and 4, and the reason being that it's between 0 and pi over 2. Even if I have 2x, that simply means that I'm doubling the range. So sine inverse of 0 gives me 0. So I just check out quadrant 1, which is 2x equals to 0, and which is x equals to 0 ultimately. That is not the required turning point. Why? Because that looks like a minimum point and I'm not interested in that. Then I look at quadrant 2, that's 2x equals to pi minus 0, x equals to pi over 2. Again, that's on the edge. It's not something I'm looking at. So I go on and look at the other one. Yes, someone told me that this looks like it's right there between 0 and pi over 2. I just, why don't you just write 45 degrees and get it done with? And the answer to that is simply that you need to calculate, okay? You won't get 6 marks for just merely guessing answer. And it might not necessarily be true. To be honest, it looks to me as if it's a little towards the left and not exactly midway between 0 and pi over 2. So let's try to solve this, okay? Now there are various ways to solve this. I could use identities for cos x and cos 2x and sin 2x. But what is clicking in my head right now is that I can somehow convert this into a tan identity. So if I bring this down here, I get tan x tan 2x. And what that does for me is it simplifies the question a little bit. So 2 tan x over 1 minus tan square x. On the other side has 4. So I cross multiply 4 minus 4 tan square x equals to 2 tan square x. So I get 6 tan square x and 4 over 6 tan square x. 4 over 6 is 2 over 3, and then a root appears. So I would technically have both plus and minus on the root, but to be honest, that's unnecessary. Why? Because I have it just between 0 and 90 degrees. So I can just say that alpha equals to tan inverse of root 2 over 3, and that should solve my problem. It is in quadrant 1, so I don't really need to mark my quadrants. I know that alpha always appears between uh, 0 and 90, so that's 0.6847, that's 685, and that is the correct answer to this question. Moving on to the next one. The diagram shows the curve this, the length of the equation, the when x equals to a, the tangents to the curves are parallel. That means that the dy by dx should be equal for both. Okay, so I'm saying that the dy by dx for the first one is e power 2x minus 3 into 2. And the dy by dx for the second one is 2 into 1 over x. When I plug in x equals to a, so this becomes 2a minus 3, the gradients become equal. So I think that's a relatively simple question. I want to make this as the equation. This is technically a question from my iteration, which has the first part as a differentiation question, and you'll see these questions appearing later on as well. I think the 2 cancels out, so that makes it a little more convenient. I need an ln, so let's introduce ln on both sides. So this becomes 2a minus 3 equals to ln1 minus ln a. ln1 is 0, so 2a minus 3 equals to minus ln a. Then 3 moves to the other side, and I have my proof. Let's then look at question number 9. It says the equation of a curve is this. Show that by dy by dx is never negative. So this looks like a quotient rule to me, where I have more or less the same expression. Okay, so 0 minus e minus x. Okay, e power minus x into minus 1 is minus e minus x. V dash is 0 plus e power minus x. Minus minus again gives me that. So dy by dx should then be, we just solve it on the next page rather than sticking to this page. Okay. So dy by dx for the quotient rule is u dash v minus v dash u over v squared. So u dash v minus v dash u over v squared. Let's first simplify this, then see what the objective of the question is. I see that e power minus x can be brought out as a common, so I'm going to say that this becomes minus 1 plus e power minus x and minus 1 minus e power minus x, and that gives me 1 minus e power minus x whole square. Okay, I've taken a common from the numerator. That gives me the denominator, the simplified numerator e power minus x, and this gives me minus 2. These two cancel out with each other. So can I then say that if I want to prove that the numerator, that the dy by dx is always negative, I can say that the numerator is always negative. And since I missed a square in the denominator is always positive. Therefore, overall fraction is always negative. That's enough of a proof. The gradient of the curve is equals to minus 1 when x equals to a. Show that a simplifies to this equation. So dy by dx at x equals to a is minus 2 e power minus a, 1 minus e power minus a whole squared. It's equals to minus 1. Let's try and simplify this. I don't need, if you look at the proof, I don't need negative a's, I need positive a's. So that's what I'm going to do right at the start. I think these minus signs cancel out, and I'm going to write this as whole square and 2 over ea. So this becomes a squared 2ab plus b squared, and this is on the other side. Okay, I can take a common denominator, or I can actually do this as well. Okay, let's just take a common denominator. I think that's easier to explain for me. E power 2a, so that's e power 2a minus, this is missing an e power a, so e power a plus 1 equals to 2 e power. the e power a, and this would become, uh, if I were to bring it to the other side, let's bring it to the other side first. Okay, the powers would get subtracted, and I would end up with 2e power a. Moving this to the other side will give me 4e power a plus 1 equals to 0. So I've proved to you whatever the question was asking me to prove. That is what the question was asking me to do. Hence, find the exact value of a. Now I'm asking you for the exact value of a. So this is an exponential equation. I cannot solve it directly. I will need to take a substitution. Let's call this e power a as u. This becomes, let's use a different variable. I've already used u before. Let's call that p. So this becomes 4p, this becomes p squared, this becomes plus 1 equals to 0. I use a quadratic formula to find out the value for p minus b plus minus root of b squared minus 4ac over 2a. And I will use this on my calculator. 1 minus 4, 1. So I'm getting p as 3.732 and p as 0.26. That's the exact value. Exact value. So I need to use an exact value. Okay, let's use an exact value. This gives me 2 plus root 3 and 2 minus root 3. Okay. Then this has to be e power a. So this becomes a equals to ln 2 plus root 3. And a equals to ln 2 minus root 3. Now, why is only one of these videos, one of these answers correct? Is because when you calculate this, this is a positive answer and this is a negative answer. It's not that there's an ln and there can't be a negative answer. It's the restriction of the question where you see that x has to be greater than 0 since a is a value for x. Therefore, it is has to be greater than 0, and that gives you the correct answer. In the last question that we have for this marathon, I am on June 11 question variant 3, and this is question number 8. It looks complicated, but it's not that complicated. I can just keep the when I'm differentiating, I can just keep 5 outside and then sort of meddle with it later on, and I can say that u equals to sine cube x, v equals to cos square x. So u dash is 3 sine x square into cos x, and v dash is simply 2 cos x power 1 into sine x minus sine x. And then I go on and apply my product rule, which is u dash v plus v dash, let's just put a minus outside, v dash, because there was a minus with the sign, it's not part of the formula. What I see as common is there was 5 outside as well. Okay, so what I see as common is I can see a sine square x common, and I can see 1 cos x common. So I get 3 cos square x minus 2 sine square x. Now in the past I've seen that this first one gives me values that are either on the edges, so it doesn't really work. So I have 3 cos square x minus 2 sine square x equals to 0. I have 3 cos square x equals to 2 sine square x. So I get 3 over 2